Welcome to Shift Change, the Idaho Manufacturing Podcast. Over the course of about 20 minutes, we bring you conversations on AI, tech, and the future of Idaho manufacturing. Funding for this program comes from Total Care IT, your Idaho-based IT and cybersecurity partner for manufacturers.
You know, we often hear about AI transforming our world in these sort of abstract ways, right?
Big picture stuff.
Exactly. But have you ever stopped to consider where it's making some of its most immediate, tangible impacts right now?
Yeah, like on the ground level.
Right, especially in places you might not always think about first. Today, we're doing a deep dive into AI in manufacturing. Specifically, how this, powerful technology is fundamentally reshaping factories, production lines, and maybe most importantly, the very nature of the workforce within them.
And what's truly fascinating here, I think, is that we're witnessing this pivotal shift. We're moving beyond what we called Industry 4.0.
This was all about the digitization, the automation.
Exactly, all that connection. And we're stepping squarely into Industry 5.0.
Right.
And this new era, it really emphasizes a human-centric approach. So AI isn't simply about, bringing in more robots for the dirty, dull, dangerous jobs.
The classic view.
Yeah, it's more about making these increasingly complex systems work with people synergistically. And that brings with it a really unique set of challenges and, frankly, immense opportunities.
Okay, so our mission today is to really unpack this huge transformation for you, our listener.
Well, let's do it.
We'll explore everything, from the incredible efficiencies and honestly almost futuristic capabilities AI enables on the factory floor, to the very real hurdles, things like human confidence, the critical demands of data security, and just the sheer scale of infrastructure needed.
Yeah, the practical side.
We'll be navigating that core tension between AI's immense world-changing potential and, the practical, often human-driven barriers to getting it adopted everywhere.
Okay, let's unpack this then. When you talk about AI in manufacturing, we're not just discussing robots bolting things together, right? Or automating the same old repetitive tasks.
No, it's much, much deeper than that now. It feels like we're truly talking about a revolution in, process control, real-time decisions, overall efficiency.
Absolutely. If you connect this to the bigger picture, AI is fundamentally changing the very DNA of how factories operate.
The DNA.
Yeah, it's moving beyond those traditional kind of rigid rule-based systems.
If X, then Y.
Right. To dynamic, adaptive ones that can analyze these vast, complex data sets in real time and continuously optimize operations. This drives better efficiency, accuracy, decision-making across the entire production lifecycle, not just in little pockets.
And we're seeing this play out in some, truly astounding ways across the industry already.
Oh, yeah.
Take predictive maintenance, for instance. So instead of waiting for a machine to just break down.
Which is hugely disruptive.
Hugely. AI models analyze this constant stream of real-time sensor data, think like minute-by-minute vibrations, temperature changes, pressure.
It's subtle signals.
Exactly. It's like giving every piece of equipment its own little internal doctor, spotting the earliest signs of trouble before a failure actually happens.
Rolls-Royce is a famous example, right? With their jet engines.
Yeah, predicting maintenance needs practically mid-flight, and the impact is undeniable. Siemens, they reported a 20% drop in unplanned downtime, 25% lower maintenance costs.
Wow.
And General Motors, they saw unplanned downtime fall by 25%, and their machinery lifespan actually extended by 15%.
So this isn't just about fixing things faster.
No. It's fundamentally transforming operations from, a reactive cost center into a strategic predictive advantage.
That proactive capability is, it's a genuine game changer. It shifts the whole maintenance paradigm. You go from costly, disruptive repairs
Firefighting
to intelligent, informed, scheduled interventions. What those numbers really show is AI minimizing disruption and maximizing asset life like never before.
Yeah.
Factories can run with unprecedented continuity.
Exactly. But it's not just about looking ahead, right? That same precision is also revolutionizing what happens right now on the floor, especially quality control.
Real-time quality, yeah.
Imagine AI-driven computer vision systems, high-res cameras, advanced algorithms, constantly scanning products moving down the line.
Seeing things we can't.
They can detect microscopic defects, tiny color inconsistencies, misalignments with astonishing accuracy, often better than the human eye, especially over a long shift.
Definitely. Consistency drops off.
Right. Coca-Cola, for instance, they used AI vision systems and cut defective units by a massive 80%.
80%.
And Boeing actually increased assembly line accuracy by 30%. Think about that level of precision on everything from a soda bottle to an airplane wing.
That's a huge leap in ensuring consistent product quality. And because AI systems can spot defects the moment they happen, not just at the end.
You catch it early.
Right, you drastically cut waste and rework. It's about building quality in from step one, which, boosts brand reputation, customer satisfaction.
And it goes even further, doesn't it? Right into the heart of how production itself is managed. Process optimization.
AI isn't just following some static plan anymore.
No fixed schedule.
No. It's dynamically adjusting production schedules on the fly, optimizing how you allocate resources, materials, machine time, even people.
Finding the best mix.
And even enhancing energy efficiency across the whole place. Tesla's gigafactories, for example, use AI to optimize energy use in battery production. They cut electricity use by 15%.
15% is significant at that scale.
Huge. And Unilever, on a different tack, improved their forecast accuracy by 10% using AI for supply chain optimization.
Which means less waste, fewer stockouts.
Exactly. A more resilient, responsive manufacturing ecosystem overall.
So what's actually making all this possible? What's the tech behind it?
Well, it's really a powerful confluence of advancements. We're talking vastly improved computing power, for one.
Moore's law is still kicking.
Sort of, yeah.
Yeah.
Plus the widespread adoption of cloud and, importantly, edge computing.
Processing data closer to the source.
Precisely, so you don't have latency issues. And then there's the Internet of Things, IoT, these tiny, ubiquitous devices everywhere.
Sensors on everything.
Right. Continuously collecting and transmitting this, frankly, torrent of operational data from every sensor, every machine, every station. That data is the foundation AI uses for these dynamic, intelligent decisions.
Okay.
And you mentioned supply chain optimization earlier. AI is proving absolutely crucial there. It helps with demand forecasting, inventory levels, even managing supplier relationships better, reducing overproduction, preventing those costly stock shortages.
These transformations, from predictive maintenance to optimized supply chains, they sound almost futuristic. It almost makes you wonder. Here's where it gets really interesting for me. This isn't just about AI replacing humans, is it?
No, absolutely not. That's a common misconception.
It feels like something far more nuanced is happening, like augmenting human capability, changing roles fundamentally.
Precisely. There's a great quote from Carl Hutter, the CEO of ClickBond, Inc. He said these big AI investments are not to replace talented human beings. They're to augment the capability of those talented human beings.
Augment capability. I like that.
Yeah. And Industry 5.0 explicitly champions this human-centric AI.
Yeah.
It envisions humans playing a much more prominent collaborative role. It's about enhancing our creativity, our problem-solving skills, our strategic thinking.
Rather than just making us redundant.
Exactly. We're seeing the rise of cobots, collaborative robots integrated with AI.
Cobots, right. Not the big scary ones in cages.
No, these are designed to work safely alongside human operators. They assist with repetitive tasks, heavy lifting, awkward movements, improving efficiency and safety for the people on the floor. It frees humans up for higher value work.
Okay, so if AI is augmenting human potential, what does this actually mean for the people on factory floor day to day? Because despite these amazing advances and clear benefits, AI adoption isn't always smooth sailing, is it? And it very often seems to come down to a crucial, maybe overlooked factor, human psychology.
That's an excellent point. What's often overlooked, I think, is that the biggest barrier isn't always the tech or the cost. It's fundamentally human. We're seeing a significant trust deficit. If people don't genuinely trust these systems, if they don't understand them or feel confident using them.
They just won't use them effectively.
Exactly. They won't integrate them into their daily workflows, no matter how capable the AI might be on paper.
And the numbers really back this up starkly. A Pew Research Center survey found, 63% of U.S. workers use AI minimally or not at all?
That's right. A huge number.
And a primary reason cited was low confidence. This often boils down to something psychologists call technological self-efficacy.
Which is basically
your belief in your own ability to use the tech effectively, right? Think about it. If someone hands you this complex new tool you don't fully grasp.
You hesitate.
You hesitate. You fear you'll mess it up or look incompetent. And then there's that persistent, almost mythical fear. The John Henry story.
Yeah, man versus machine.
Of being replaced by technology, which can, unfortunately, lead workers to actively resist AI or even subtly try to, outmuscle it, undermining its potential.
And look, that's not just an irrational fear sometimes. It's often fueled by the inherent nature of many AI algorithms themselves.
How so?
Well, this leads us right into the crucial challenge of AI transparency. Many advanced AI systems, especially deep learning models, operate as black boxes.
Meaning we don't know why they make a decision.
Pretty much. Their internal decision-making processes are incredibly complex, often difficult, if not impossible, for humans to fully understand. And this lack of transparency, well, it can lead to biased outcomes or flawed predictions.
Especially if the training data was bad.
Exactly. If the data fed into the AI was incomplete, skewed, or reflected existing biases, those biases get amplified. And when a system can't clearly explain why it made a particular decision, that inevitably erodes trust.
And this is precisely where something called explainable AI, or XAI, comes into play, right? It's not just a buzzword, it's meant to be a practical solution.
Exactly. XAI is all about empowering humans to, well, comprehend, interpret, and ultimately trust the results and outputs from machine learning.
Open the black box.
Trying to, yes. It aims to describe the AI model itself, its expected impact, highlight potential biases, characterize its accuracy, fairness, transparency, and the rationale behind its outcomes. The goal is making these opaque models more transparent by revealing how they arrive at decisions, not just what the decision is.
And there's specific methods for this, like shape and line.
Yeah, those are two of the most popular and effective ones. A shape stands for Shapley Additive Explanations.
Okay.
And LIME is Local Interpretable Model Agnostic Explanations. Think of them as AI's internal auditors, in a way.
How do they work, roughly?
Well, SAP helps us understand which inputs, maybe a specific temperature reading or vibration frequency, were most critical to an AI's overall decision about a machine's health. LIME, on the other hand, can zoom in to explain why the AI made a specific prediction for one particular piece of equipment or flagged one specific defect.
So one gives the big picture, the other the specific case.
Kind of, yeah, like getting a transparent reasoning sheet for each individual outcome with LIME. And these methods are used everywhere: healthcare, cybersecurity, and definitely manufacturing, providing both that high-level overview and the granular details.
Okay, that makes sense.
Indeed, SAP and LIME are consistently highlighted across different fields because they're versatile. They give clear, actionable insights, often focusing on which features mattered most for a prediction, or explaining individual predictions by approximating the complex model with a simpler, interpretable one locally.
And that seems invaluable in manufacturing. Understanding why a defect was flagged or what pointed to a potential failure. That leads directly to process improvements, right? Not just detection.
Absolutely. It closes the loop.
So it's clear then that this shift, moving from traditional manual labor to these more technical AI-driven roles, it requires a really serious proactive investment in people, in their skills.
You're absolutely right. Traditional manufacturing roles are evolving rapidly. Workers increasingly need proficiency in data analytics, understanding IoT integration, managing AI systems.
It's a whole new skill set.
It really is. We're talking about a significant transition from purely manual tasks to supervising, interpreting, and managing AI-enhanced processes. This needs new skills in system monitoring, troubleshooting AI alerts, even basic data interpretation. It's like a new kind of literacy for the factory floor.
Okay, so beyond these crucial human factors, the confidence gap, the skills, what about the sheer practical, almost physical challenges of bringing AI to scale? This is where it hits the infrastructure, right?
That's an enormous point. One of the biggest constraints, and maybe one of the least discussed, isn't just the software algorithms, it's the physical infrastructure.
Meaning?
There simply isn't enough power, compute capacity, networking bandwidth, or data storage globally to meet AI's escalating demand.
Really? We're hitting limits.
We are. We're squarely in what many call the second phase of AI. We're moving fast from chatbots that just answer questions intelligently
to AI agents.
Exactly. Agents that can conduct complex tasks almost fully autonomously. And that kind of capability is incredibly resource intensive. It requires vast data centers that consume enormous amounts of energy and specialized hardware.
And then there's this significant data gap you mentioned earlier. AI is great with human data, images, text, speech.
It's learned that pretty well.
But it hasn't been as effective with machine data, that continuous rapid-fire stream of time series data from sensors, equipment logs. Why is that kind of data so challenging for AI?
It's a fantastic question. The challenge with time series machine data isn't just its sheer volume, though that's part of it. It's the nature of the data itself.
How so?
It's often incredibly granular, continuous, and it contains these subtle, often nonlinear correlations that are really difficult for traditional AI models to parse effectively, especially without extensive, high-quality, often human-labeled data sets specific to each machine and its operational context.
So you need really specific training data.
Very specific. Plus, machine data often experiences something called concept drift.
Meaning the patterns change.
Exactly. The underlying patterns or relationships change over time due to machine wear, environmental factors, software updates. So models trained on old data can quickly become irrelevant or inaccurate. This complexity means getting truly actionable insights from machine data for things like subtle anomaly detection or precise optimization. It's still a frontier for AI.
And that reliance on vast amounts of data, coupled with all these interconnected systems, that brings us straight to critical security and privacy concerns, doesn't it?
Absolutely. It's unavoidable. AI systems depend heavily on this continuous flow of data from IoT devices, sensors, connected platforms. This makes data security job number one.
Priority one.
Consider the real-world impact. Back in 2021, there was this devastating ransomware attack on a global manufacturing firm. It caused significant operational delays, huge financial losses.
Ouch.
And it starkly highlighted the vulnerabilities in these highly connected AI-driven environments. Implementing robust cybersecurity measures like, say, zero-trust networking isn't just good practice anymore, it's paramount for survival.
Pretty much. Assume no user or device can be trusted inherently, even if they're inside the network perimeter. Requires strict verification for everything. But it's not just about using AI for security anymore, it's also about securing the AI itself.
Protecting the AI from being tricked.
Right. From adversarial attacks, data poisoning. This also extends to meeting specific compliance standards, things like CMMC 2.0 for defense contractors or ISO 20001 for general security management. These are becoming table stakes, especially for manufacturers in critical infrastructure or defense. It's about protecting the integrity of the AI's decisions, not just the data it uses.
Speaking of infrastructure and resources, the AI revolution is undeniably hungry for energy. It's a fascinating paradox, isn't it? It truly is. The immense power needed for training these large AI models, running the massive data centers, powering all these connected devices, it adds up to a significant energy footprint.
Which raises sustainability questions.
Big time. This escalating energy demand clearly calls for sustainable power solutions and, frankly, more energy-efficient AI architectures. But here's the double-edged sword. AI itself can be a key to conserving energy.
How so?
By optimizing industrial processes, managing smart grids more effectively, fine-tuning machine cycles to reduce waste, intelligently controlling factory heating and cooling, AI can significantly cut electricity consumption, so it can actually become a crucial part of the sustainability solution, even while being energy-intensive itself.
Okay, so we've covered the incredible potential, the human trust gap, the infrastructure needs, the security challenges. What does it actually take to unlock AI's full potential in manufacturing, to overcome these multifaceted hurdles and shift from potential to widespread reality?
That leads us right to thinking about what's needed from policymakers and industry leaders. It absolutely requires a structured, strategic, and crucially, collaborative approach.
Not working in silos.
Definitely not. Policymakers should actively foster an environment that supports AI innovation and adoption, and they need to leverage industry expertise to create relevant frameworks, not just impose rules from afar.
And a huge part of that has to be providing relevant and role-specific training, right? And I emphasize specific.
Yes, absolutely critical.
This isn't about generic intro to AI courses. It's about job-specific, user-centered programs tailored to the actual devices, the software, the daily situations workers face.
Like that research on adult educators showed, right? Training has to be directly relevant to be effective.
Exactly. This means things like cohort-based training with feedback loops, maybe even engaging low-stakes formats like prompting parties.
Prompting parties, I like that.
Yeah, where workers can experiment with AI, learn from each other, build confidence in a supportive environment instead of feeling thrown into the deep end.
That makes sense. Beyond training, though, robust policy and financial incentives are vital.
Money talks?
It does. Governments can provide crucial financial incentives, subsidies, targeted tax credits, grants for AI adoption, especially for small and medium businesses, the SMEs.
Who often struggle with the upfront costs and risks.
Precisely. Policy should also actively promote sustainability in AI deployment and establish clear industry-wide standards for things like data interoperability, safety, ethical use, that ensures a level playing field and consistent quality.
And a huge piece of this whole puzzle has to be collaboration, doesn't it?
Couldn't agree more. Meaningful partnerships between manufacturers, tech providers, academia, policymakers, they're absolutely crucial.
Breaking down those traditional barriers.
Yes. This could include things like establishing open data platforms to share anonymized, aggregated machine data. Remember that data gap we talked about?
Yeah, for the time series stuff.
Sharing that kind of data responsibly and securely could massively accelerate AI model development for everyone. We also need to foster innovation hubs or research centers where different stakeholders can experiment together, collaborate, and rapidly speed up getting cutting-edge AI tech into real-world factories.
So it's about bringing everyone to the table.
Ultimately, yes. Building truly cross-disciplinary teams. Combining that deep domain expertise from the factory floor with the technical AI knowledge. It's about strategically addressing workforce skill gaps through good corporate training and strong partnerships with educational institutions to shape relevant curricula.
Making sure the education matches the need.
Exactly. This ensures we have a workforce that can not only use AI technologies fully, but also engage with them actively. And importantly, it helps mitigate those fears of job displacement by focusing on how human-AI collaboration leads to better jobs, higher paid, more technical, maybe even more fulfilling roles.
So it really boils down to making sure that as the machines get smarter, faster, more capable, the people using them feel genuinely empowered, supported, and confident, rather than feeling intimidated or, worse, left behind.
Yeah.
Wow. Okay. What a deep dive into this fascinating and, well, truly complex world of AI in manufacturing.
It really touches everything.
We've explored how it's revolutionizing everything from predictive maintenance and precision quality control to dynamic process optimization, really transforming factories into these highly efficient, adaptive, increasingly intelligent systems, bringing us, as you said, squarely into Industry 5.0.
And we've also hit those critical challenges head on. The significant trust deficit that can really hinder adoption.
That human element.
The absolute necessity for relevant job-specific training, those vast data gaps, especially with machine data, and the paramount importance of robust cybersecurity for these super connected AI systems.
Yeah.
Ultimately, it feels like it's about making AI not just powerful and efficient, but also transparent, secure, ethical in how it's used, and fundamentally human-centric.
Indeed. From everything you've shared today, it seems clear the future of manufacturing isn't really about AI replacing us entirely.
I don't think so.
Instead, it's about augmenting our capabilities, creating entirely new jobs, often more technical, more strategic, and fostering an era of increased productivity, safety, and hopefully innovation.
But
it requires that intentional, sustained effort in training and education and really fostering confidence for all workers.
across every generation, right?
From Gen Z just starting out to baby boomers adapting decades of valuable experience.
Absolutely. And this also raises, I think, an important final thought for you, our listener, to consider. As these AI systems become more autonomous and, frankly, more seamlessly integrated into our daily lives, reaching far beyond just the factory floor, how do we collectively ensure that this emphasis on human trust, on transparency, on collaboration continues to be the driving force behind its development? Not just in manufacturing, but across all the industries AI is starting to touch.
A lot to think about, as always.
Thanks for joining us on today's episode of Shift Change. To learn more about using AI in your manufacturing business, reach out to Total Care IT, your Idaho-based IT and cybersecurity partner for manufacturers.